Hi everyone. In today's class, we shall discuss about fluid kinematics and continuity equation. This is the starting of your unit 2. What do you mean by fluid kinematics? In the first unit, I have mentioned that kinematics is the branch of science which deals with considering the pressure forces acting on the liquid. So such study is said to be fluid kinematics. So once I may recapping this fluid kinematics. Fluid kinematics is a study of fluids when the pressure forces are not considered and the fluid is in motion. And the next part is continuity equation. So after this session, we'll be knowing what are the types of classifications of fluid flows and streamline and stream tube, what do you mean by rate of flow and continuity equation. So first classification of fluid flows. So the fluid flows are classified as the following: steady and unsteady flow, uniform and non-uniform, laminar and turbulent, compressible and incompressible flow, one dimensional, two dimensional, three dimensional flows, and rotational, irrotational, and the last is viscous and inviscid fluids. So first we shall go with steady and unsteady flow. So whenever the fluid is flowing in a path, if the properties of the fluid does not differ with velocity time, such fluid properties or such fluid flow condition is said to be steady state condition. Right now I mentioned here that if the properties may not differ from point to point with respect to time is said to be a steady flow. So dv by dt is equal to 0. So that is case with steady flow. If the properties of fluid changes with respect to time, then it is said to be unsteady flow. Okay. Similar with uniform and non-uniform. If we consider only the velocity, if the velocity of the fluid does not changes with respect to position and time, then it is said to be a uniform flow. For example, flow of water in a pipeline at a constant diameter and constant velocity is the best example for uniform flow. For every condition, the properties or the velocity changes from point to point. So that condition is said to be non-uniform flow. In an open channel, if the water is flowing, then it is set a best example for non-uniform flow. So I hope you are all clear with what do you mean by steady and unsteady flow, uniform and non-uniform flow. So now we go with next flow type, that is laminar and turbulent. A laminar flow in which the fluid flows in a straight and parallel to the path. Such types of flow is said to be a laminar flow, and the flow through capillary tube is the best example for laminar flow. And the most important example for the laminar flow is the blood in the veins and arteries. If it is not in a laminar, then our body blood circulation will be different, which may cause us unhealthy issues. Okay. And for turbulent flow, wherever the changes in velocity, and if it is eddies or mixing action, and the velocity may be varied from point, such kinds are called as turbulent flow. So in this diagram, you can see the fluid flows in a path, in a specific path. So that is laminar. Here the path is not maintained and the velocity is also very different. So in a better manner, if the fluid path is in straight line, then it is said to be a laminar. If it is in a zigzag way, then it is a turbulent flow. For a better understanding of laminar and turbulent flow, in your next topics, we are having an experiment called as Reynolds experiment, which is used for finding whether the flow is laminar or turbulent. If the Reynolds number is less than 2300, then it is said to be a laminar flow. And if it is a greater than 2300 and between to 4000, then it is said to be a transition flow. And if the fluid Reynolds number is more than 4000, then it is said to be a turbulent flow. So which will be discussed in the further topics. So the next property or next fluid flow is, the next fluid flow is compressible and incompressible. Almost all fluids are incompressible, which means the density will be changing from pressure changes. So such types of fluids are called as incompressible. Whereas in compressible fluid, the density of the fluid will be constant. Sorry, here both it is mentioned as incompressible. I'll change it. And the next is one-dimensional, two-dimensional, and three-directional flow. If the flow parameter is taken as velocity and it is function of only time and in one coordinate only, then it is said to be a one-dimensional flow. If similarly the velocity function is taken in two coordinates, that is x and y, then the flow is said to be a two-dimensional flow. And similarly, if it is taken under three dimensionals, x, y, z, then it is a three-dimensional flow. And the next type of fluid flows are rotational and irrotational flow. In the rotational flow, the fluid particles flow in the straight line and also rotate about their own axis, are said to be a rotational flow. And if does not rotate with respect to their own axis, then it is said to be a irrotational flow. And next is viscous and non-viscous fluids. In viscous fluid, the effects of viscosity are important and cannot be ignored. Such kinds of fluid flows are called as viscous flows. And the visual effect, the flow effects of viscosity are significantly influence of the flow and not considered, then it is said to be a inviscous flows. So these are the classifications of fluid flows. And next we go with the topic streamline, stream tube, and path line. A streamline is a line. Whenever you draw the tangent to that line, we can determine the instant velocity at that particular time. Such line is said to be a streamline. Some of streamlines is said to be a stream tube. And next is streak line. Streak line and path line. First we shall go with path line. Path line is whenever the fluid wants to move from one position to another position. So if the line joining the points from initial to start end position, such points, the line drawn through the start to end points is nothing but the path line. And in the streak line, it is an instantaneous line which points occupied where the prescribed point in a streak, it can be integrated pattern. So such single point. A streak line is an instantaneous line whose points are occupied by particles which have earlier passed through prescribed. Okay, such kinds of lines are called as streak lines. So this is regarding path line, streak line, and streamline and stream tube. Now we shall go with rate of flow or discharge. We all know the general definition of discharge means moving from one place. So in considering with fluid mechanics, if the rate of flow or discharge is defined as the amount of water flowed per unit time, okay, how much quantity of fluid is flowing through a pipe per unit time is nothing but the discharge. Okay, it is units are meter cube per second and it is denoted with capital Q. And now we shall go with continuity equation. If you are taking an L pipe like this, and this is initial position 1 and this is final position 2, within the control volume, if the fluid is allowed to pass, the forces acting on the starting position will be equal to the second position. By steadiness, the total mass of the fluid contained in the control volume must be invariant with time. Therefore, there may exist balance between the total rate of flow in the control volume and the mass of flow is equal to total mass in flow. Okay, so density into velocity into area is equal to position 1 to position 2. As it is an incompressible fluid, which means density is constant, so rho will be cancelled. So V1 into A is equal to velocity into area is 1 is equal to velocity at 2 and area is equal to 2. So area into velocity is nothing but discharge at inlet is equal to discharge at outlet is said to be constant. So Q is equal to A1 V1 is equal to A2 V2. So this is a continuity equation in two-dimensional equations. And the next is these are the sample short answers and essays which were asked for your university examinations. Thank you.